We are now going to discuss circles. At the end of the lesson, the students should be able to use the basic principles concerning the circle to illustrate properly and solving diligently application problems. The circle. A circle is the locus of point that moves in a plane at a constant distance from a fixed point. The fixed point is called the center, which has the designation C is equal to HK since it is an ordered pair, and the distance from the center to any fixed point on the circle is called the radius, R. In representing a circle analytically, we will be using the second degree equation x squared plus y squared plus dx plus ey plus f is equal to 0 for some constants d, e, and f is the general equation of the circle. So on your circle, you would be having your center and your distance from the center to any point on the circle, which is your radius. For some parts of the circle, we will be discussing the following. 1. A chord. A chord is a straight line joining 2 points on the circumference. So any point on the circle joined by another point on the circle by a straight line is your chord. The longest chord is your diameter. The diameter passes through the center. A segment of a circle is the region enclosed by a chord and an arc of the circle. So this is a minor segment. It is that region. Or it may be a bigger segment or the greater segment. A secant is a straight line cutting the circle at 2 distinct points. So if we will be having a line that passes through the circle at exactly 2 points, it is a secant. And if the straight line and a circle have only 1 point of contact, then the line is called a tangent. So if the line intersects to the circle at a single point, that is a tangent line. The tangent is always perpendicular to the radius drawn to the point of contact. Analytically, we will be considering or we will be describing the circle using the center, HK, and the radius, the distance from the center to any point on the circle XY. So we would be needing the HK or the center of the circle and R, the radius of the circle. From the definition of the circle, it is the locus of points which moves so that its distance from the fixed point is constant. So we have the distance from the point XY to the point HK is constant R. And recall that the distance formula for the distance between 2 points is given by d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared equal to the distance. So if the first point is the locus, which is xy, and the second point is the center, which is constant at hk, we would be having the formula r is equal to the square root of x minus h squared plus y minus k squared. If we will be squaring both sides, we will be eliminating the radical, so we have r squared, which is equal to x minus h squared plus y minus k squared. Simplifying this, we would be arriving at x squared minus 2hx plus h squared plus y minus 2ky plus k squared is equal to r squared. This is applying binomial expansion. Simplifying this further, we would be having x squared plus y squared, and then the linear terms minus 2hx minus 2ky, and then the constants h squared plus k squared, and then if we're going to transpose r squared on the other side, we have negative r squared equal to 0. We can rewrite this one in terms of given constants. So we have x squared plus y squared plus dx plus ey plus f is equal to 0. For the coefficient of x, we have negative 2h is equal to d. For the coefficient of y, we have negative 2k is equal to e. And for the constant f, it is equal to h squared plus k squared minus r squared is equal to 0. So d can be solved as negative 2h, e negative 2k, and f equal to h squared plus k squared minus r squared. And if we want to solve for h, k, and r, it would be negative d over 2, k is equal to negative e over 2, and r is equal to the square root of d squared plus e squared minus 4f is all over 2. So you can have that summarized to the list of formulas for the circle. Let's have an example. Find the equation of the circle with center negative 1, 7, and tangent to the line 3x minus 4y plus 6 is equal to 0. We have the center negative 1, 7. And we have a tangent line 3x minus 4y plus 6 is equal to 0. For the equation of the circle, you would be needing the equation of, the center and the radius. We have the center already, negative 1, 7. But the problem is, how are we going to get the distance of the radius? So what we're going to do is to find the distance of this point to this line, and that would serve as the radius. Taking note that the tangent line is always perpendicular to the tangent line is perpendicular to the radius, thus it would be the shortest distance. Therefore, we can get the distance from the point to the line using the formula d is equal to ax plus by plus c all over square root of a squared plus b squared. In this particular case, we will be having the equation at the given point negative 1, 7. Plugging it in, so we will be having 3 times negative 1 minus 4 times 7 plus 6 all over the square root of 3 squared plus negative 4 squared. So we will be having negative 25 for the numerator. It's negative 3 minus 28 is negative 3 minus 28 is negative 31 plus 6 is negative 25. Dividing it by 9 plus 16, so 9 plus 16 is 25, square root of that is 5. 25 over 5 is 5. So we are now ready to substitute or plug into the equation hk and the radius. So we would be having x minus negative 1 plus y minus 7 squared is equal to 5 squared. So we have x plus 1 squared plus y minus 7 squared is equal to 25, or we can simplify that as x squared plus y squared plus 2x minus 14y plus 50 equal to 0. As a second example, find the equation of the circle having 8, 1 and 4, negative 3 as the ends of the diameter. So we have, how are we going to solve this problem? we need a center and a radius. So what we can do here is to get the midpoint of the endpoints of the diameter, because on your circle, if you have the endpoints of the diameter, the midpoint is your center. So we would be taking the average of the coefficients, 8 plus 4 over 2, and 1 plus negative 3 over 2. That would be the center. And for the radius, so the length of the diameter is twice the radius. So what we're going to do is to get the distance between these 2 points. So using the distance formula and divide it by 2. So it would be 8 minus 4, which is, or 4 minus 8 anyway would be squared, so it would not really matter. So 4 minus 8 is negative 4 squared, plus negative 3 minus 1 is negative 4 squared. So this would be 4 squared 16 plus 4 squared 16. So 16 plus 16 is 32. So that would be square root of 32 over 2. We divide it by 2 because the radius is half of the diameter. So dividing this, so we will be having 2 square root of 2. And again, the midpoint is 6 and negative 1. 8 plus 4 over 2 is 6. 1 plus negative 3 is negative 2. Over 2 is negative 1. And we can plug it into the equation and we arrive at x minus 6 squared plus y plus 1 squared is equal to square root of 8 squared, or 8. Here are some of the additional problems. Reduce to standard form and draw the circle whose equation is 4x squared plus 4y squared minus 4x minus 8y minus 31 is equal to 0. So first, we need to divide the entire equation by 4 so that we would be eliminating the numerical coefficients 4 and 4. So we have now x squared plus y squared minus x minus 2y is equal to 31 over 4. We can use the formula or we can complete the square. So from the formula, your d is negative 1, your e is negative 2, and your f is negative 31 over 4. If you have just memorized the formula, you can substitute these values to solve for for h, k, and r. But if you don't have memorized the formula, we can do completing the square. So that would be x squared minus x. So we have negative 1. We divide it by 2, so negative 1/2 squared, and then we arrive at 1/4. For y, we have negative 2, divide it by 2, so that is negative 1 squared is 1. Whatever we add on the left side must also be added on the right side. So we add 1/4 and 1 to the right side. So on the left side, you would be having x minus 1/2 squared and y minus 1 squared. Simplifying the right side, so we have 31 plus 1 is 32 over 4. 32 over 4 is 8. 8 plus 1 is now 9. Observe how number 4 is solved.